Hello everyone, welcome to this video on central limit theorem part 6. In this video, we will see how to apply central limit theorem to solve this problem. The problem is there are going to be 30 electronic devices D1, D2 up to D30 which are used in the following manner. As soon as D1 fails, D2 becomes operative. When D2 fails, D3 becomes operative and so on. If the time to failure of any of the component Di is exponentially distributed random variable with parameter lambda equal to 0.1 per hour and T is the total time of operation of all the 30 devices, find the probability that T exceeds 350 hours using central limit theorem. So, we first find that the problem is about central limit theorem. Under central limit theorem, we know that the classification can be done on two categories. One is X bar and the other one is Sn. Go search for the keywords whether you have them as average or mean or any quantity for your X bar, or if it is Sn, then you must find something like sum, total and so on. So now we can see that this problem talks about find the probability that T. What is T? T is the total time. So we have something called as total. Hence the problem is all about Sn. So we begin the problem with step number 1. Identify the formula for your Sn. So what is your Sn given by? Sn follows normal distribution with mean n mu and standard deviation sigma into square root of n. Step number 2. Identify what are the data requirements. What are the data required? N, mu and sigma. From the problem, we know that the number of components taken for analysis is 30. Therefore, I have n to be equal to 30. Now, the remaining two quantities to be discovered are mu and sigma. We don't have any direct information on mu and sigma, but we have been told that each of these di follow what distribution? Exponential distribution. Now, recollect that f of x is equal to lambda e power minus lambda x for x greater than or equal to 0 for your exponential distribution, which has a mean which has been given by 1 by lambda and variance which is given by 1 by lambda square. And what is lambda? Lambda is called as the parameter of the exponential distribution. Now, let us search for the second keyword. We have been said it is exponentially distributed with parameter lambda is 0.1. So, we know that lambda is going to be 0.1. Now, substitute it in the quantity called as mean. So, it is 1 divided by 0.1, which makes it as 10. And variance is 1 divided by 0.1 the whole square, which makes it as 100. So, I have now mu to be equal to 10. And what does variance stand for? Sigma square is 100 and hence your sigma will be square root of 100, which is again equal to 10. So, I have the data which has to be required for substituting in the formula ready. Now, move on to step number 3. What is my step number 3? Identify the formula with the given data, which means Sn follows normal distribution with n mu. So what is my mean? 30 times of mu. So 30 times of 100. And what is going to be my sigma? Sigma is 10 times of square root of n. So what is square root of n? Square root of 30. So now this gives me Sn follows normal distribution with 300, 10 root 30. So this is going to be my mean and this is going to be my standard deviation. Point number 4. Identify what the problem is all about. We have been asked T is the total time of operation of all the 30 devices. So we have device 1, if it fails then device 2, if it fails then device 3 and so on, all of them get operative and finally we have device 30. So the total time of operation of all the 30 components is my t. So they have asked me what is the probability that this total time of operation t exceeds means greater than 350. So 350. So now the problem is to identify the probability of t greater than 350. Convert the problem in t to z. Then I can apply normal distribution to solve this problem because I know that Sn follows normal distribution. So this will be greater than 350 minus, we know that z is equal to x minus mu divided by sigma. Okay. So in place of x, I write 350. In place of mu, I will write it as 300 divided by, in place of sigma, I will write it as 10 into square root of 30. Now use your calculators to convert this data and estimate what is it equal to. Using our calculator, we arrive at z greater than 350 minus 300 divided by 10 root 30 to be equal to 0.9128. Since our normal distribution table has only two places of decimal, I round it off to 0.91. So this is going to be the value which I am going to find. So now draw your normal distribution chart. Okay, so normal distribution curve is going to be a bell-shaped curve. In this bell-shaped curve, I have the center line as z is equal to 0. So I have the quantity z equal to 0.91 to lie in my positive region. So let me mark this as z is equal to 0.91. What is the requirement? Greater than, which means I require the portion which is going to be more than 0.91. Which is the portion more than this? This is the portion greater than 0.91. Now how to estimate this portion? We know that whenever we have greater than symbol, remember the code word GST. So what is it? Greater means subtract. Subtract from where? What do you know about half the area of this chart? It is going to be 0.5. The table can read only from the center line. So from the center line to 0.91, find out what is your table value. So go search for 0.91, 0.9 and 1. So what is 0.91? Here is 0.9 and here is 0.1. So the requirement is 0.5 minus probability of 0 less than z less than 0.91. So it is 0.5 minus the table value for 0.91 is 0.3186. So subtract it from 0.5, you will be arriving at 0.1814. So the probability that the total time of all the 30 devices to work to exceed 350 hours is estimated as 0.1814 using your central limit theorem. Thank you.